Hello everyone. Okay, so we are going to look at using Crammers rule to solve systems of equations. Great. Okay, so make sure you watch the first video where I explained how to find the determinant of a 3 by 3 matrix. Great. But before I can be able to solve an examination question, in this case a 2025 GCE, first let me take you through, show you the steps how you can be able to find the solving systems of equations using Crammers rule. Okay, so if say suppose I have the system of equations, okay, systems of equations, okay, I have a1 x plus b1 y plus c1 z is equal to d1, a2 x plus b2 y plus c2 z is equal to d2, a3 x plus b2 b3 plus c3 z is equal to d what, d3. So this is the system of what, equations. Okay, now basically I want to to find the values of x, y, z, like that. So by Crammers rule, first you are supposed to come up with an augmented matrix. How do you come up with an augmented matrix? In this case, you just basically get the coefficients from the variables x, y, as well as z. So you say let A be equal to, you will form a matrix by basically getting the coefficients. So I have, this is A1, I have A2, I have what? A3, like that. Then I have B1, I have B2, I have B3. Okay? I have C1, I have C2, I have C3. And the variables which I have are x, y, as well as z. And this is basically equal to the what? D1, D2, as well as D3, like that. Okay, so now how do we use the concept of Crammers rule? So basically, you are supposed to come up with in this case I've come up with the first augmented matrix. You're supposed to come up with an augmented matrix with respect to the x values, an augmented matrix with respect to the y values, as well as an augmented matrix with respect to the z values. How do you come up with that? So you say your A in this case, okay? Your A in this case is this one, which is A1, A2, A3, B1, B2, B3. Then you have C1, C2, as well as C3. So you come up with the what? An augmented matrix. In this case, we're talking about A with respect to the what? The x values. Okay. So how do you come up with that? So if I have my matrix A with respect to the x values, this basically means that I'm supposed to substitute. On the x values, I will substitute with the what? The d values. Therefore, I'm going to have, if I substitute there, this will be d1, d2, as well as what? d3. The rest will remain like that. I have b1, b2, as b3, c1, c2, c3. Okay. Similarly, my augmented matrix A with respect to the y values, meaning wherever I have the y value, the y coefficients, there is b1, b2, b3. You've seen, huh? So this I'll substitute with the what? The d values. Then what am I going to have? So A values remains A1, A2, A3, like that. Okay. Then these coefficients from y. Okay, I'll substitute with the d values. I'll have d1, D2, D3, like that. The C values will remain like that. I'll have C1, C2, C3, like that. Similarly, the augmented matrix A with respect to the Z values, in this case I'm supposed to substitute what? The Z value, the Z coefficients, which I'm calling them to be values. So C1, C2, C3, I'm substituting by the D values. So what am I going to have? A1, A2, A3 remains the same, B1, B2, B3. But in this case, I'm talking about the coefficient with respect to Z. I'll substitute. I'll have D1, D2, as well as what? D3. Then from here, by Crammers rule, I'm supposed to find the determinant of matrix A. I find the determinant with respect to the x values. I'm supposed to find the determinant with respect to the what? Y values. I'm supposed to find the determinant with respect to the Z values, like that. Once I find all those determinants, then I'll say by Crammers rule, I'll have to find the x value. This is basically equal to their determinant of A with respect to the x values divided by the overall determinant. Similarly for y, the determinant, okay, of A with respect to the y values over A determinant. Z similarly of the determinant of augmented matrix A with respect to the Z values divided by the what? The overall determinant. So by Crammers rule, this is how one can be able to find the values of x, y, as well as what? Z, like that. Yes. So now let us try to to use what I've explained, in this case the Crammers rule, to solve systems of equations in additional mathematics 2025 GCE as our example. Great. Okay. 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 Okay, so the question is as follows. Okay, the question is as follows: 2025 GCE ADMA. Okay, so question is solve the following. Okay, solve the following systems of equations, like that. Okay, great. We have 2x minus 3y plus z is equal to 11, x plus y plus 2z is equal to 2, 3x minus 2y minus 3z is equal to what? 7. So here we are going to say, okay, we get the coefficients. So we have, in this case, we have 2. Okay, we are looking at the x. We are getting the coefficients. So this is x. So here the coefficient is 1. Okay, then 3, we have negative 3. There the coefficient is 1. The coefficient there is negative 2. This is just z. This means the coefficient is 1. This is 2. The coefficient there is negative 3. Okay? Then the values we have x, y, z, and this is nothing but equal to, we have 11, 2, as well as 7. Great. So our a in this case is this one, 2, 1, 3. We have negative 3, 1, negative 2. We have 1, 2, negative 3, like that. Then the augmented matrix A with respect to the x values, in this case, this means we just substitute on the coefficient of x, we'll substitute with, these coefficients. Then what are we going to have? 11, 2, 7, neg 3, 1, negative 2. Okay, these are, maintained like that. Similarly, the augmented matrix with respect to the y values, in this case we are just substituting the what? The y coefficients, these which I'm calling to be the what? The values. So now look at, we are going to have 2, 1, 3, then I'm substituting, I have 11, 2, 7, then 1, 2, negative 3 will remain like that. Okay? The values with respect to the z, I'm just substituting, basically these are the z coefficients which I'm going to be values. So if I substitute here, these would remain the way they are. 1, 2, 3, negative 3, 1, as well as negative 2. So I'm substituting, I have 11, I have 2, and I have what? 7. Then the next step is that I'm supposed to find the what? The determinants. Okay, for each augmented matrix. So I'll start with the over. In this case is I'm looking at matrix A, like that. So my matrix A here, okay, this is a 2. Remember, elements are assigned signs from what? In the other video I explained from, this is positive, the first one, so this is 2. Okay, and then I'm supposed to delete the row as well as the column. Then I'll remain with 1, 2, negative 2, as well as negative 3. 1, negative 2. So this is okay. I'm remaining with 1, 2, negative 2, and negative 3. Negative 3, like that. Okay, so the next element is assigned a negative. Okay, so I'm going to say minus, this is negative 3, like that. Then if I delete the row as well as the column where that element is placed on, I'm remaining with 1, 3, 2, and negative 3. 1, 3, 2, and negative 3. 1, 3, 1, 3, 2, and negative 3. The next element is basically positive, so I'll say plus 1, and if I delete this, I'm going to remain with 1, 1, 3, and negative 2. 1, 1, 1, 1, 3, and negative 2, like that. Okay, therefore, the determinant for A is equal to, this is 2. This is a determinant of a 2 by 2. 1 multiplied by negative 3 is negative 3, minus negative 2 multiplied by 2, that is negative 4. Okay? Negative times negative, that is a positive. 1 multiplied by negative 3, that is negative 3. Minus 3 multiplied by 2, that is 6. Plus 1. 1 multiplied by negative 2, that is negative 2. Minus 3 multiplied by 1, that is 3. Like that. Therefore, this is 2. This is negative 3. Negative times negative, that is positive, then I'm going to have negative 3 plus 4, and this is just 1, plus 3, negative 3 minus 6, this is basically negative 9. Okay, then I have plus 1, negative 2 minus 3, this is basically just negative 5. 1 by that, this is just a negative 5. And this is nothing but equal to 2. 3 multiplied by negative 9, that is negative 27 minus 5. Okay? And then 2 minus negative 27 of negative 25 minus 5, that is negative 30. Therefore, the determinant for A is what? Negative 30. Great. So, next I have to find the determinant with respect to the what? The xk values. So now, I've found my determinant, which is equal to negative what? 30. Now I want to find this. Okay? I find this as well as this. Then like that. Great. Okay? Let us find the second one. Okay? Let's find the second one. Okay? So let us find the second one. Great. Okay. Okay. This was 3, this was negative 2, this was 7, this was 2. Okay. So in this case we are dealing with the what? AX. I'll just write the matrix 11, 2, 7. This is negative 3, this is 1, this is negative 2, this is 1, 2, as well as what? Negative 3. Right, we want to find the what? The determinant. And this is equal to. So the first one is positive. Then if I delete this, what am I going to remain with? I'll remain with, okay, 1, 2, 1, 2, negative 2, as well as negative 3. The second one is a negative. Okay. If I delete like this, okay, what am I going to remain with? 2, 2, 7, and negative 3. So 2, 2, 2, 2, 7, and negative 3. The third is a positive, plus 1. If I delete this, what am I going to remain with? 2, 1, 7, as well as what? 2, 1, 7, as well as negative 2. Great. Therefore, this is 11. The determinant of a 2 by 2 matrix. So this is negative 3. 1 by that. Minus that by that. That is negative 4. Negative to a negative, that is a positive. Okay. And then 2 multiplied by negative 3 is negative 6. Okay. Minus 7 multiplied by 2, that is a 14. Like that. Okay. Next, this is plus 1. 2 times 2, that is negative 2. This is minus 7. Like that. Therefore, this is 11. Okay. Negative times negative, that is positive. This should be negative 3 plus 4, that is 1 plus 3. Negative 6 minus 14, that should be negative 20 plus, this is negative 2. Let's see, 2 multiplied by 2 is not negative 2, but negative 4. Then minus 7 multiplied by 1 is 7. So this is nothing but equal to negative 11. Like that. Therefore, I'm going to have this multiplied by that. This is positive 11. Then this should be 3 by that. It should be a negative 60. Positive times negative is negative 11. 11. This is negative 11. This is 0. And I'll remain with what? Negative 60. Therefore, the determinant of augmented matrix A with respect to x values is negative 60. Great. As for the third one, I'll do the same thing. Okay, you can just write it. Okay. 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 Great. So I have this. Then coefficients. We have 2, 1, 3, 11. I have 2, 7, 1, 2, -3. Like that. Okay. Okay. 2, 1, 3. 1, 2, -3. 11, 2, and 7. The determinant of this matrix is given by, first one we know is positive. Okay. By now we should all know what is happening. If I did it, okay, this as well as that, what am I going to remain with? 2, 2, 7, and -3. The second one is a negative, the second element. If I delete this, what am I going to remain with? 1, 3, 2, as well as -3, like that. Great. The third one is a positive. So what happens if I delete? I'm going to remain with 1, 2, 3, as well as 7. Great. You can find this is 2. Okay. 2 multiplied by -3, that is -6, minus 7 multiplied by 2, that is 14, minus 11. 1 multiplied by -3 is -3, minus 3 multiplied by 2, that is a 6, plus 1. 1 multiplied by 7, that is 7, minus 3 multiplied by 2, that is 6. Great. Therefore, I have 2. -60 minus that, this is basically negative 20 minus 11, -3 minus 6, that is -9, like that, plus 7 minus 6, that is 1. 1 multiplied by 1, this is just 1. Therefore 2 multiplied by -20, that is -14. Okay, great. And negative times negative, that is positive. Okay. 11 multiplied by -9, that is positive 99, plus 1, and this is -14, plus 99 plus 1, that is 100. -40 plus 100, you basically get what? Positive 60. Therefore, the determinant is what? Positive 60. So we can solve the determinant for the last part. Okay. In this case, we're dealing with this augmented matrix. Great. Simple. Okay. Okay. Great. So we want to solve the determinant for this one. Okay. Great. Okay. Great. Okay. So as the determinant is equal to, the first one is positive, like that. The second, what happens? We have to delete the column as well as the row. What are we going to remain with? 1, -2, 2 and 7, minus -3. We delete this. What are we going to remain with? 1, 2, 3, 7, plus 11. The third element is a positive. If we delete this, what are we going to remain with? 1, 1, 3, -2. Correct. Okay. So this is 2. 1 times 7 is 7, minus -2 multiplied by 2, that is -4, negative times negative positive. Okay, 1 multiplied by 7, that is 7, minus 3 by 2, that is 6, plus 11. 1 by negative 2 is negative 2, minus 3 by 1, that is negative 3. That's 3. Great. Therefore, this is 2. Negative times negative, that is what? Positive. So I have 7 plus 4, then plus 3. 7 minus 6, that is 1, plus 11. Negative 2 minus, negative 3, that is negative 5, like that. This is, 7 plus 4, that is 11. Multiplied by 2, that is 20 what? 22, plus 3 multiplied by 1, that is 3. Then I have, this is 11, okay? Minus 5, that is, we are multiplying here, negative 55, like that. Great. 22 plus 3, that is 25, minus 55. And this is nothing but equal to negative what? Negative 30. Great. So the determinant here we found it is negative what? 30. Great. So we've managed to find the determinants. Therefore, by Crammers rule now, by Crammers rule, okay? Let's go. By Crammers rule, let's see the values we are going to get. By Crammers rule, okay? Let's see by Crammers rule what we are going to get. So by Crammers rule now, Crammers rule, we know to say x is equal to what? The determinant with respect to the x value divided by the overall determinant. Y, the same thing, the determinant with respect to the y coefficients divided by the overall determinant. For z, the same thing, the determinant with respect to the z values divided by the overall what? Determinant, like that. We can substitute. Here we had found that this was negative 60 divided by the overall negative 30. The determinant for, it was 60 divided by the overall negative 30. Here we have found the, it was negative 30 divided by the overall, which is also negative what? 30. So a negative divided by negative, it is a positive. 30 into 60, we'll get 2. Like that. Great. Positive 2. Here, positive divided by negative is basically a negative. 30 into that, we'll get what? Okay, we'll get a negative 2. Okay? Negative into negative, we'll get, that's a positive, and this is basically what? 1. Like that. So therefore, x is equal to a positive 2. Okay? Y is equal to negative 2, and z is equal to what? Positive 1. Let us try to, to prove if our values are correct. Just try to prove if what we found is correct. Okay. So how do we prove this? It's very simple. We'll say where there is x, I can put what? I can put the x value, which is 2. So this is 2 by 2 minus 3. Where there is y, I can put negative 2. Then plus z, which is 1. So I'm supposed to get what? 11. So this is 2 times 2, which is just 4. Negative times negative plus 6. Okay? Plus 1. This is basically 11. So the first one is done. Then on the second one, if I plug in the values, I'm supposed to get 2. So let's see. I'll put, this is x is 2, and my y is negative 2, plus 2, my z is 1. This is 2 minus 2 is 0. 2 times that, I'll get 2. So, proven. Let's just look at the last one. If I get 3, okay. Where the x value is 2 minus 2, the y value is negative 2 minus 3, I'll put 1. So 3 times 2 is 6. Negative times negative is positive 4. Negative 3 times 1 is negative 3. 6 plus 4, that is 10 minus 3. This is what? 7. Great. So this means that our values are correct. So thank you for paying attention, and make sure to subscribe, leave a comment,